Let's learn about a new input. This one is the ultrasonic ranger, and I have here for your experimenting enjoyment an ultrasonic ranger. You have one in your kit. It is called HC-SR04. That's the official designation for this thing. And I want you to just take a look at it to begin with. If we look at the back side, you will notice that it has a bunch of chips on it. It's got a bunch of logic on board. So this thing, just judging by all those chips, it does some sort of thinking on its own, which is just good to know. That's the first thing to consider. There's some sort of intelligence built into this. What does it actually do? Well, I want you to notice these two big metal cans on the front. One of them is labeled T, one of them is labeled R. And if you were to just add an X to the end of both of those, you'd have TX and RX, which we learned what that means on the Arduino. It means transmit and receive. And indeed, this T is the transmitter and the R is the receiver. Well, what's it transmitting and receiving? Well, it turns out the way this thing works is you face it towards something. So let's say it's facing towards my hand in this case. The T can is actually a speaker. And it sends out little chirps, very high frequency chirps, about 40,000 hertz. It's sound, but it's not sound that you and I can hear. Maybe a dog or a cat or a bat or a dolphin or some other critter who can hear higher pitched frequencies than we can would hear it, but we will not hear anything happening when it's running. It sends out chirps from this speaker, and then those chirps will echo. They will bounce off of a surface, for instance, in this case, my hand. They will bounce back to the R, the receiver, which is acting as a microphone. If you send some chirps from here, they bounce and they return back, and if there's an echo, if you have a good timer, if you had a really fast stopwatch, you could say, well, how long did it take my chirp to return? And then based on that, figure out how far away that thing was the sound bounced off of, provided you know the speed of sound. We do know the speed of sound. And this thing, please note that it has this metal can up top. You may recall from when we talked about the Arduino components, that was a component that is a very high speed pendulum, like a little clock that ticks really fast, tick, 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 very quickly. This one is not labeled, so I don't know, but let's just call it 1,000,000 times a second or something. That little thing ticks. And anytime you see one of those, that's a big clue that there's some sort of high frequency timing or some sort of high accuracy timing going on whatever hardware that's attached to. So indeed, this thing is able to time the time of flight for sound between here and here, the round trip time, which is on the order of microseconds for a short distance. How are we going to connect this to an Arduino? Well, first of all, I'm just going to show you the schematic drawing of this thing. So some parts like a resistor has a specific drawing, or a capacitor, a potentiometer, an LED, these have specific symbols, but this is just a part that does not have a specific symbol. What we can do, it's a totally reasonable practice and it's used in electronics all over the industry, is just label a rectangle, just as we did with the Arduino. We just simply labeled a rectangle and we label all the pins on it. So this thing has a pin on top. That first pin up here, it's labeled VCC. What VCC means for our purposes is the same thing as power. And in this case, I'm going to just write whatever the label is here. I'm going to write it on my schematic. VCC can be connected to 5 volts. Now, that does not mean VCC is not the same as 5 volts. Sorry, my video froze. It'll resume momentarily. VCC is not the same thing as 5 volts. In our circumstance, VCC can be substituted for 5 volts because this device uses 5 volts as its standard. It also has a ground. And you'll notice that I am writing VCC at the top and ground at the bottom. It has 2 other pins. And this is the ground pin. It's labeled GND. The other pins are trig and echo. So what do those pins do? Oh gosh, video froze again. Sorry. What do trig and echo do? Well, trig is short for trigger. And that is a place where the Arduino is going to send this thing a signal that says, please start doing your chirping. And echo is the pin on which this will talk back to the Arduino and say, this is how long that sound took to bounce back to me. So the trig, I'm going to label it on the left here, trig, because that is data coming into this thing, and the data going back out will be echo. I should have given myself a little bit more space. So this is a perfectly valid schematic symbol for this thing. How will we wire it to the Arduino? Well, it's pretty straightforward. The Arduino has that, and the Arduino also has a ground pin. So we can attach this ground pin to the Arduino's ground pin by doing that. We can attach this VCC pin to the Arduino's 5 volts. So that is how we will power it. By the way, no resistor is needed. We can just plug it straight into the Arduino. So then what are we going to do with these other pins, the trigger and echo? Well, I'm actually going to leave that to the side for the moment. We're going to come back to it because the software that we're going to be using for this is actually going to tell us where to plug these other 2 pins into the Arduino. And prior to looking at the software, we don't really know. So let's take a step over into software land. To use this part, we're going to want to add a new piece of software onto our computer, onto the computer that's like running the Arduino software that you don't probably already have. And this is the first time we'll be adding what's called a library. Under the Tools menu, select Manage Libraries. If you get a new piece of hardware, it's very common that you're going to want to download a new piece of code to talk to that hardware. Somebody else has already done the work of writing the code, and a good place to start is by looking for the part number. And you can just do a search for that in the library and hit enter. And please note that there are many results here. So just looking through these, the very top one appears to be written in Swedish. Okay, so that's perfect for people who want to find out how far things away are from the board in Sweden. Here's somebody who is running like some sort of learning camp for kids. Sorry again about this camera. Who wrote some particular library just to interface with them for that camp. There's a lot of options here. And how do you know which one's a better one and a worse one? It's actually pretty hard to tell. You could click on the more info and you will get typically to a GitHub page where there's information about that project. And if there's like more documentation, that's a really good sign. If it's well written, that's a really good sign. If these are like complete sentences with proper capitalization, that's a good sign. Any attention to detail that you're seeing, that usually means that that's a better bet for that hardware, for that software rather. But generally speaking, you can kind of go shopping in this world of libraries and then download something that looks like it might work. In this case, I'm actually going to recommend a library called NewPing. That's one word with no space. On this computer, it says installed because I have already installed this, but you will have the opportunity to install it. Then you will have a copy. The thing you're downloading is a very small file. It should download very quickly. It's on the order of like 10 or 20 kilobits. Pretty small, kilobytes, I'm sorry. And that will be added into your Arduino software automatically. So that when you go under the File menu, go to Examples, and go down to the very, very bottom, Examples from Custom Libraries. I've only got 2 custom libraries on this particular computer. There's this Adafruit NeoPixel library, and there's the one we just downloaded, NewPing. If you did the download yourself, you should also be finding this. The library came with examples. That is what we're looking at here. And I think we'll just look at NewPingExample. So any good library, the person who wrote it will supply you with examples to show you how to use that library. Otherwise, they're just kind of sending you into the wild and saying good luck. It's always a good sign when they actually include an example. So let's look together at the example. This one is very wide text, so my head's going to be in the way some of the time. Sorry. At the top, there's this big comment, example NewPing library sketch that does about a ping about 20 times per second. A ping being the action of sending out a chirp and listening for an echo. Include NewPing.h. We're going to see this a bunch of times. This hash include is a special line that means go to your computer and look for a file called NewPing.h. That is, by the way, the thing you downloaded. You downloaded NewPing.h and NewPing.cpp, which is a C++ file. Those are the things that are actually the meat of the library. You also downloaded these example files when you did the download. If you look carefully on your computer, you can find NewPing.h, and if you want to read exactly what is in that library and even modify it, you are welcome to do that. This line, please note, it does not end in a semicolon. This is an unusual line for us. These lines that begin with the pound sign and a word like include, they don't end in a semicolon. If you put a semicolon there, you might actually get an error. The next line, and so what this is really saying is to the Arduino software, go find that file, NewPing.h, and just paste it here. like put the contents of that file above whatever else you may write below it. So that's like the way it includes or attaches the library to your software. These next three lines, hash define trigger pin 12. I want you to think of this as the same thing, essentially the same thing, as const int trigger pin equals 12. So it's not truly all the way completely identical the same, but it's very, very close. So when you see these hash defines, just think of that. What it's doing is it's saying, whenever I see the words trigger pin, I will substitute in the number 12. The same with echo pin and the same with max distance. Aha! Please look carefully at what the library says. Apologies again for the wonky camera. Trigger pin equals 12. Echo pin is 11. Those are big major clues. That's actually telling us how to wire this thing up. So now we can actually complete the schematic based on reading the library, because the library is telling you actually, here's where things go. So just to, let's just hop over and finish that. Trigger pin is 12, so I'm going to be using pins 12 and 11. Trigger is going to go to 12, and echo is going to go to 11. Now we've completed the schematic. Okay, now going back to the software to understand what it's actually going to do. There's this thing here that says NewPing, and then the word sonar, and then some stuff in parentheses. And that stuff in parentheses was just defined up here. Max distance, by the way, and you could read the comment, maximum distance we want to ping for in centimeters. So this can, in theory, the sensor can sense about 2 meters, that's about 6 feet, of distance. In reality, you're not going to see distances that long, usually. What this line is doing is making a new object called sonar. If you're familiar with object-oriented programming, that's the kind of object I'm talking about when I say object. This is the thing that in software we'll be able to use to talk to the part. Now, in void setup, we have serial.begin. What's a little funny about that? It's actually running at a higher speed. It turns out you don't only need to put the number 9600 in there, you can put numbers other than that in there. It's possible. And we're going to remember that number, 115,200, because when we want to talk to the Arduino, we're going to need to put that number in a particular place. Let's look at the loop. It says delay of 50 to start with, 50 milliseconds, and please note, wait 50 milliseconds between pings. And just to scroll over and look at the rest of that note, 29 milliseconds should be the shortest delay, between pings. So that's that is useful information. So that means if you didn't have a delay that's at least a certain length, 29 milliseconds, then you could actually mess up something or get bad data. You probably won't harm the device, but maybe you could. Probably not, though. What is actually happening? So start with a 50 millisecond delay. It's kind of a funny way to begin, but so be it. This is the example from the library, so we assume it's written well. Serial.print, and then ping with a space after it. Please note that this is serial.print, not serial.println. So it's not going to hit return at the end. All this is going to do so far is make the Arduino say to the computer, ping : space, and not hit return. The next thing it's going to serial.print is apparently sonar.ping_cm parentheses. What is that? Well, that thing right there, that thing that is highlighted, that is the whole reason you downloaded the library. That thing is doing all the work behind the scenes of talking to the hardware. What it's going to do, the library is going to send a signal on the trigger pin to the device. The device, the sonar device, the HC-SR04, it's going to send out a ping. It's going to listen for an echo. It's going to reply to the Arduino with how long that echo took to get there. And this same thing, sonar.ping_cm, is going to interpret the incoming data from this, change it into centimeters of distance, and give you that number back. So the thing that I've highlighted is a whole bunch of work happening behind the scenes in the library, in the NewPing library, which is the whole reason to download it. Could you write your own thing that would do all those functions? Sure you could, but no need. Somebody else has done that work, so just take advantage of it. All of that stuff is going to end up with a number. So let's say the number 36, because something is 36 centimeters from the sensor. So then it will be doing effectively serial.print 36. Finally, after that, so it'll be ping : space 36, then the letters CM. And that's a serial.print ln, so it's going to actually hit enter after that line runs. So that is the totality of the code. It's made pretty short and sweet by the fact that we're using a library. The library is doing a bunch of heavy lifting for us. Let's do the wiring, which shouldn't be so hard. We're just going to follow what our schematic says. I like to, I'll just get a little bit farther away. I like to, well, certainly have the schematic with reference to this thing, so that I'm just comparing the top and the bottom and just going wire by wire. If you just take it one wire at a time, you will succeed. If you try to do a bunch at once and you're just looking at the breadboard, things get complicated really fast. I'm going to plug this in like this, facing out, so that I can like move my hand back and forth and get some data off of it. When it is plugged in, it's pretty much universally a good idea to begin by plugging in ground. So I'll plug in my ground wire over here. I'm looking at the board from the side to make sure I'm plugging it in the right row. If I plug it in the wrong place, I can harm this chip. If I push power into ground and ground into power, I could destroy this chip potentially. So always good to start with that. Then I'll add the power. So 5 volts should connect to this 5 volts. And I'm using a red wire for that. The colors help you not make mistakes. I highly recommend using good colors. Next, I will use a different colored wire, in this case a green one, no special reason, to connect the trigger pin to pin 12. And finally, the echo pin to pin 11. Now, if we wanted, for some reason, to use pins 11 and 12 for something else, like we're building some complicated machine and we really want to reserve those pins for something else in our machine, we could just in the software reassign those pins. In this case, sometimes if you try to reassign pins, you'll cause trouble. But in this case, it's perfectly fine. Now it is wired up. I'm going to plug it in to the computer. And let's see if I can upload this code. Should get some blinking when the upload happens. Blink, blink, blink. Yes. Okay. And now, nothing. I'm not seeing anything. Well, it's because I didn't open the serial monitor. The data is coming back in the form of the serial monitor. And I'm actually going to hide that for a moment because the serial monitor has a funny thing we need to make sure to adjust. Okay, so here's what the serial monitor looks like right now, and the important part is hidden behind me. Please notice that I'm getting a whole parade of backwards question marks. Not so helpful. In fact, that's kind of confusing. What you should do to avoid the parade of backward question marks is set the correct baud rate. That number down there, that 9600, is what we usually have, but I gotta match the rate at which the Arduino is sending data, because there's a mismatch right now at the rate it's sending data and the rate it's receiving data. So if I fix that, now, aha, I'm getting actual numbers. And if I put my hand close to the sensor, I see 4 and 5 and 6 centimeters. If I move my hand farther away, the numbers get bigger. And it's pretty responsive because there's only 50 milliseconds of delay between these events of sending and receiving the data. So what if you want only to use the number and you don't want all that ping and stuff? Well, I can actually just comment out this line, and I'm using command/ as a quick shortcut to comment stuff out. I can comment out this line. Now, if I upload this code as written, I want you to look at it for a moment. What will the serial feedback look like? Think about that. If you answered, it will be a number, followed by another number, followed by another number, followed by another number. You were right. And just to see it, just to confirm your suspicion, there's a slight flaw in this code as currently written. And the slight flaw is we never hit enter. So these are valid numbers. These are perfectly right, but they're not separated from each other in any way. So it's basically impossible to parse, both for you and for the computer. So the thing we have to fix is serial.print ln. That's going to make sure that there's a new line after that number. I'm going to upload that, and this is just going to be the numbers. I'll open the serial monitor. Aha. There we have some nice numbers. And in fact, if you wanted to graph those nice numbers, which you are welcome to do anytime you have numerical data, I recommend graphing it. That helps you really see what's going on. Under Tools, select Serial Plotter. The serial plotter, I'm sorry, it's opening in a funny spot. The serial plotter shows very jumpy data. It's kind of hopping all over the place. If I move my hand closer, yeah, it goes down. If I move it farther, it goes up. And if I move my hand out of the way, it's jumped up to what looks like about 120, but it's still kind of hovering. Something comes in. So an important lesson is that not all data is beautiful and clean. In fact, the data coming off of the ultrasonic ranger is pretty noisy. You can expect it to kind of be all over the place. And now I'm going to face it towards me and get closer and farther from the sensor. If you have a large thing, a large target, you can tend to read farther distances. If you're reading close-up distances, you can probably do okay with a small target. The sensor works best from like maybe 5 to 50, 60 centimeters, something like that. All right, so that's a really cool input and usable for all sorts of things. Maybe you want to measure how many people are walking through a doorway. Maybe you want to measure how far away an object is from your device. Maybe you want to put a few of these on a robot, and the robot is going to know when it's about to run into a wall. All sorts of possible applications for the ultrasonic ranger. And if you want to use it, you can just add this stuff, including the library and this stuff, to another sketch. And you could save sonar.ping_pingcm. You could save that into a new variable. You could say int distance equals sonar.ping_cm. You can just copy this thing. And then you would have it. So you can do much more than just merely print it out to the serial monitor, of course. You can actually do something with it in your code. I hope you think of something neat to do with this, and I hope when you plug this in and got it running, it actually works for you.